Okay, so like as I mentioned before, we forgot to make I forgot to make the volume simulation from the mountain tip RBD. So in order to achieve that, now we're gonna drop in a loop. And so we go back inside the mountain tip RBD. We're gonna put a point loop, hook the first input to mountain debris. Let's rename this to source pyro. Source pyro. Oops. What is wrong with my keyboard? Source pyro, and let's go inside and let's put a fit range, hook up our age to the value input, and then change the source max to 1.5. Okay, let's drop in a ramp parameter so we can change the curve if needed, or the color, and then let's drop in a multiply again. This time let's get the CD, multiply with the result of the our ramp, and then let's export this out as this guy out as fuel. So let's bind export again and call it fuel, and this multiplied guy, let's copy paste this and let's call this one temperature. Yes, it's correct. Okay, and finally we can hook this up to the CD so we can see what we're generating. Okay, let's get out of the popnet, and then let's drop in a time blend. Okay, hook it up to our source. We don't need to get in. Let's keep so let's drop in a wrangle. Now I'm gonna do a little bit of cleanup. Let's say if that CD is less than 0.025, remove point. Okay, so that's gonna remove some of the brighter, darker particles. We should have decent velocities. We don't need to do anything with the velocity. So what we're gonna do now is that I'm going to put a time shift here to define my initial size, which is at 1077. Well, I don't think we need this. I had it anyway, so let's leave it. Let's call it null. But if we set the start frame to the 1077, that's sort of fix this anyway. Let's call it initial. Now we need to drop in a .NET. Change the start frame to 1078. That's what I did. 1078. Let's hook up the first input to dop imports input 0. Okay, let's go inside. Now we're gonna do again the same thing like we did before. Smoke object, we're gonna call it fire object, or smoke object, or anything you wish. So I'm going to copy paste the initial settings. This is gonna look for the size of our cache, the first frame. So let's get of our first frame of our simulation. This is now Y size, and Z size. Why is it a different color? I did something wrong. That looks correct. I locked it, I think. Oh yeah, I did lock it. Oh, okay. and then we're gonna get the centroid as well. Paste Y, paste Z. Okay, we don't want a closed bound, obviously. Now we're gonna again bring in the particles into our .NET by using apply data together with subgeometry, and in subgeometry we are going to use the first input here, and we need to change the operation to always, so we always get the data refreshed. Okay, and then now we need to drop in a Pyro solver under here again. Okay, the first input, so the Pyro solver settings is under simulation 1, temperature diffusion 0.2, cooling rate 0.2, buoyancy 1. Under combustion settings, ignition temperature 0.1 and burn rate is 0.9, temperature up to 5, and I don't want any explosions, I just want fire. Let's go to smoke, create dense smoke, turn it on, which is going to create dense smoke. I even have the smoke amount set to 2. Gas is default, and I think I have advection, which is at 5. Well, that's quite high. We may need to investigate that. Under the shape settings, dissipation is set to 0.5. Disturbance is set to 0.5. Turbulence is set to 4. Okay, and under disturbance I am using temperature field on velocity, so let's add that. And my value control influence is 0.5. Remember, these values are very much related to what comes out from my particle sim, what I'm feeding into the simulation, so you may have to play with your settings to get something similar. So swirl size under turbulence 10, grain 0.6, and it's using density again. The settings are left alone. Under the advanced tab, I am again using my OpenCL CPU. Okay, so that's that, and then we need to now define our container size, auto, not already freeze, resize, gas resize fluid. So this guy, I changed the padding to 1. So padding is basically if your volume is moving so fast, it kind of adds on top of where it detects, I guess, whatever the field it's looking for. So we're gonna tell .NET to follow tip simulation out activate. Is this? This is not. This is the name. This name is the wrong name. Out activate is at. Where is the node I'm looking for? Oh, here. Okay. This guy, which we left here before. Okay, let's go back inside the .NET. Again, we need to bring in 2 gas particle to fields. 3, sorry. Gas particle to field. This one is fuel. Temp. Density. Oh, sorry, we need one more for velocity. And well, so let's move these guys up. U2. Merge this here. Connect all of them here. I don't think the order matters. Okay, I guess Mr. Wagner would be able to give a better answer for that. Field, not the correct place. Come on now. To destination fuel. Okay, as we have been doing. This one is using regular, assuming uniform radius. Calculation is add, and that's it, I believe. For temperature, we're gonna put under our field name temperature. Let's copy that and use it as an attribute as well. It is not accumulated. Why did it come accumulated? I accidentally pressed it, I guess. Assume uniform radius. This is also set to add. Yep, and then density also add, and we can just copy this guy here and here. Okay, so the remapping is now done. Oh, sorry, because we didn't have density, we're using fuel as a density. So it's just taking the same values and converting that into a density field, which is cool. Makes no difference for us. Velocity is again val. Attribute name is v. Assume uniform radius, and it's additive again. And this time, however, source pre-multiply change by 0.1. Okay, and these are our sourcings without the collision geo. So let's save our scene. Maybe let's save it as this time. This was my broken file. Okay, let's say solid pyro. Let's call this RBD pyro. And okay, that's not cool. I can't save anything. Nothing is working here today. Does it work? No, it did. Yes, it is saving. Okay, now we're gonna check, and then we're gonna bring in our collision geometry. Okay, did it save? Yes, we did. Okay, so pyro, let's go to 1077, which should create us a bounding box, which it didn't. Why? I'm gonna press play. Oh, I said 1078. Okay, my bad. We are kinda missing. Okay, I think I'm gonna change this guy to my source, which is this. I think that's gonna give a better tracking, hopefully. Let's see. Not really. Why is my auto size not expanding? Because it's, yeah, okay, my bad. Turn the clamp to maximum off. I think we should probably, this simulation might stretch out really big because of the because we are very close to the simulation, and the travel distance is too much. So ideally you may want to put here put a box outside and then bring it into the clamp to maximum by object, and then define the maximum simulation size that the popnet can grow to. Let's play with some visibility settings so we see more. Okay, it's density, maybe 10, I don't know, maybe too much, obviously. 2. This is without collisions. Okay, now let's bring in our collision gear, which is going to come from the particle popnet that mountain debris was created. That is still compatible because we have been using volume collision objects. So let's bring these guys in here. So in a merge node, left effects, right, and individually inspect at your creation frame that you do have. So it didn't work. Okay, let's see why it's not working. Oh, this is the other one. It should be looking for this guy. Let's check again. Terrain low. This is looking for attribute create 1, which is this one, which is correct. So why am I not seeing it? Okay, this is here. The VDB should be here. This is also here. So this should be good. Let's double check our scene. Maybe reinitialize our .NET. Creation frame 1078. Well, I'm going to hit reset button. Okay, it's here. Animated ship. This should be okay as well, which we did for the simulation before. Okay, and then the last but not least, the mountain itself, which is here. Good. So if we visualize these guys, I just don't see. Okay, that's fine. Okay, so this is good. So now if I put it on the output and press play, we should get something. This is probably quite low for now. Let's go a bit high res. If I press play, what's gonna happen? Should start seeing smoke coming out of those points. Although our resolution is not very low, maybe not that low. But we are reading a lot of data from outside, so I guess it is normal speed-wise. Okay, so what we're gonna do now is that I'm gonna cache this out so we can do a play blast in the morning. It's late here now with 0.25. What we can do is literally to cache this out. Let's go back to the last section that we created, DOP import fields and the volume resample, which was under the base crash simulation node. Let's copy all those and go back in mountain tip RBD and paste that under .NET. Do not forget to update the path for the DOP import fields. Where is it? Okay, here. So that should be okay now. Let's find the smoke object in here. Fire object, yeah, that's what we called it. I didn't have rest fields in this one. No, so if we select this DOP import field and press play, we should get some data out of that .NET, which we are. And I'm going to now simulate this so we can have a look at it. Let's save our scene. Okay, and let's update obviously the frame range. Well, this one is going to be a bit tricky because we don't want 300 frames, but I'm just going to let it run as long as it can, as long as my memory finally crashes the sim. Okay. And once that's done, we're going to come back and check. Okay, so shortly after I said I'm going to cache this out until it crashes. It crashed, but the result was already looking pretty bad. So and I played around with the settings and then came up with much nicer values. So the one thing I noticed was that it was keep growing so much. And so I introduced new attributes into Source Pyro. So please dive inside in Source Pyro, and now we're gonna add a start scale like we did in the base Pyro. So we want to multiply the amount of source over time. So please middle mouse click on input tree. So creates a new parameter, name it as key source, and this will be keyed as you can see. At 1078 the value is 1, at 1120 the value is 0, and and then I want to use this value and a starting scale value to be multiplied over time to pipe it in as a p-scale. Start scale is another parameter basically, and gets multiplied by the key source, exported out as p-scale as a float, and the result of this cache comes out something like this. Let's focus. Let's watch it together. I'm watching this for the first time also. It was caching. So if you look from our camera view, okay, in this sim we don't have temperature, and let's lift up the dark colors a little bit. Okay, I think this will do for the range of this camera. So in our next lesson, what we need to do is we're gonna go over these particles and figure out how to sort some of this stepping in two of the volume simulations, this one and the big explosion, and hopefully right after that we can start putting all the work we did together and start preparing a render scene, so we can go through the shader settings and mantra settings. Okay, thank you for watching.